Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Cisco's 8000 series router changed the game in high-end routers thanks in large part to the Silicon One ASIC. It also introduced to the industry some of the first 400 gig ports, along with Cisco's QSFP-DD form factor pluggable optics. This is episode 34, and we conclude our conversation with Amar Khan, product management leader for the 8000 series router. In this episode, we conclude with the future of optics in routing. Amar received his BSEE at the University of Oklahoma and an MBA from Santa Clara University. He started his career as member of the technical staff at an ASIC emulation startup where he worked on cutting-edge ASIC and FPGA designs. His first foray into networking system design was at another startup based out of Massachusetts. He then moved to Broadcom through the company's acquisition and launched and managed products with over $250 million in revenue. In 2010, he moved to Ericsson's IP division and defined their edge router line with an annual revenue of over $150 million. Amar joined Cisco in 2018 and has been with the 8000 series router team for over 4.5 years. He's worked on various areas of the 8000 product line, including fixed and modular systems, line cards, fabrics, optics, platform security, and more. If you haven't already, please subscribe to this podcast on Apple Podcasts. You would click the plus button at the top now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphen and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Amar Khan. So we've covered a lot of ground about the history and what's been going on with the 8000 router. Mm-hmm. What do you see next, or in the future, however far you want?
The future is very bright. I mean, we continue to execute on all fronts, including optics. You're in the middle of it, right? We're doing 400 gig optics. We're doing dense 400 gig optics, which is 2x400, 8x100. We're marching towards through IEEE when they will have their 800 gig max spec out, which should be out. We will be coming out with native 800 gig transceivers, whether they're gray or coherent. There are a lot of stuff going on in the coherent world that we're tracking and we're going to integrate. Mm-hmm. Obviously, we are working on increasing the slot capacity of 8000, and so there is a lot of exciting work going on all fronts, software included.
Oh, did you want to elaborate on the coherent optic? I thought there's a lot of architectural shifts going on.
Oh, absolutely. We are in the midst of I got a big shift, and Cisco again is at the forefront of this innovation, right? First thing that we introduced was these digital coherent pluggable optics, and then the second wave is 0 dB optics with good transmit power. What we are seeing is it's adding tremendous value to our customers, and how do we know it's adding value? There is more work, and we get more and more work, which to me translate into customers are excited about this, and there is more traction, and which I really like. And the value proposition
more work meaning there's more requests for new features?
Yeah, there are more requests for new features. Okay. Customers are asking for support of more alarms. They're asking for legacy support. They want to be able to make sure that we have more performance parameters. We have support for digital coherent modules. Through programmatic models, Yang models. So there is clearly a lot of traction, and that means the adoption. The industry is embracing digital coherent optics a lot faster than at least I had imagined. So a lot of work is going on, and this is great. from a value perspective, there is tremendous amount of value that it adds that they've added. Cisco is pushing or promoting routed optical networks paradigm, which I think is brilliant innovation that we've introduced, because it's going to create so much value for our customers, and they can just leverage what they have and use these digital coherent optics and design their network. So that is ongoing. We see a lot of good traction there. So I think
So I may be oversimplifying this, but my interpretation of that architectural shift is that when what used to require like a separate box to drive a coherent optical, larger module or line card to cover a certain distance, like say 100 kilometers or more, you can now, with the pluggable QSFP-DD, plug it straight into the 8000 router.
Absolutely.
And that opens up a totally different architecture. Is that accurate?
That is completely accurate. And, we have been using ROI models to show customers what the TCO is, right? The total cost of ownership. But what I found
so what goes into that model? Like what is the benefit of having a different architecture?
Yeah. So I'll tell you more about it. So just like you said, right? So there are two things. There are two components that are very important. There is a line side amplifiers, right, that people use to amplify their signals. There is a component called transponders, right? So transponder is what you were talking about, removal of a box. So transponders are these big components that dissipate power, they take up rack space, and you use those. So you connect them to your router through gray optics. And then these transponders will take these gray optics and they will transform them into, C-band lambdas, or what we call the tunable lambdas, or colored lambdas. If there's any other name that you can think of, please let me.
Colored for DWDM.
Yeah, for DWDM. So DWDM signals. So you take the DWDM signals and then you connect them to amplifiers. You amplify the signal, you boost them, and sometimes you don't need to, but to go the distance you have to. And there are multiple types of amplifiers, and you just do it, right? So digital coherent optics real value proposition is they remove this one layer, which is the transponder layer. And now with 0 dB transceivers that we're talking about, the real innovation is that the team has integrated the amplifier in the transceiver. So now there is no amplification needed.
So you don't need a separate box.
You don't need a separate box, right? And not only that, think about this. These boxes are deployed in the field. So you need to do truck rolls to manage them, to see if they're operational. If something goes down, you have to go fix them. And the same with transceivers, transponders.
And you got to power them too.
Right. You have to power them. You have to do all sorts of planning. You have to do a lot of work. And the other thing is that they could be in a different domain, meaning they are managed by a separate group of people or separate department. All of that goes away when you take these pluggable optics and use those to plug them in. Now the real question that our customers, and that's why I say, there's a lot of activities and a lot of work, is that our customers want to see the same with these digital coherent optics. They want to see the same amount of features that they're used to. All these different performance parameters, all these alarms, all these different things, and that's what we're doing right now. So and successfully, I might add, and that's the big value proposition. Just getting rid of all these components that are separate and they're sitting there, they're taking up rack space, or they're sitting outside and taking up some space somewhere else. I mean, you can just get rid of all of that, and that.
But you're still running your DWDM network, though, right?
You do DWDM. The RON has a proper. So when you are doing add drop muxing, or you are doing amplification, you can just use routers, connect to two routers together, TCOs, and you can do your traffic grooming, so to speak. Traffic comes in, you groom it, you can separate them out through routers, and then just connect routers together through these DCOs.
And so is that where the architectural advantage comes from? Because I can see just from a hardware BOM perspective, you take away the amplifier, that's great. You take away the need for a separate rack space for your transponder, that's great. But architecturally, how does it help to have the actual router have access to the DWDM optic?
It helps because it alleviates all these different layers that customers had to manage previously, right? So you have an
Okay.
optical layer, you have an IP layer, and also so this convergence of optical IP makes a big difference. And add, previously you had to manage an optical network, which was an overlay on IP, or IP
Hmm.
was an overlay on optical, however you want to look at it, but these were two separate networks. So with digital coherent optics, you have collapsed that layer. And now you have a
So
single layer, IP, and you're
so
just
when you had
managing.
the transponder in the mix, you had to have this optical management layer,
That is correct.
which is just running on, it's just managing that transponder because you have all these signals coming in through the gray optics into the transponder,
Yes,
and they get mixed together. They get translated into these DWDM wavelengths,
yes.
and that's a whole layer in itself to do that until
Yeah,
you take
that's
take that
correct.
layer away.
So you would put
Okay.
IP traffic on on these lambdas, right? So you have IP
Uh
traffic
huh.
running on DWDM, and then you have your whole DWDM network. Transponders goes connects into a airdrop mux, and from there it gets into an amplifier. From line amp, there are
Hmm.
three, four different types of amplifiers that you have to do. It connects to another airdrop mux, then it goes to other transceiver. So
Hmm.
now you don't need this. I mean, if you can groom or add drop traffic or change traffic profile or by just connecting two routers together, which we do that already.
So so you take away the optical add drops too when you do this. You don't
You
need them
know,
anymore.
this is something I'm not. This is not my domain, but I think in some
Okay.
cases you can, but in some cases you don't have to, because in
Okay.
large networks where the span is too big, add drop muxes are still used. You don't eliminate all of them entirely, right? But what
Maybe
you
if you're just upgrading a ring network or something, you still want to maintain
probably.
the
Uh,
optical add drops or something.
I'm pretty sure that's probably the case because that's not my domain, like I said. But one thing I
Okay.
do know where the value is added from a TCO perspective, it is in the elimination of this first layer, which was just the transponder layer, where you are
Hmm.
all it is doing is converting your gray optics into DWDM signals, and
Hmm.
you just eliminate that by DCOs, and then that alone has resulted in more than 50% savings. And
Wow.
the part that I find very fascinating is that we have been promulgating and we have been promoting this, going out teaching, evangelizing this. But one of our customers did the case study, and this is exactly what they concluded. And it's readily available, but they're presented in some seminars as well. So it
Mm.
clearly makes a big difference. So, elimination of that fact and the fact that you have now fixed boxes with really, really high throughput, 8,000 fixed boxes. You can use those. They support digital coherent optics. You can plug them in. You just completely eliminate, this big router that you had previously, replace it with a more efficient, high throughput router like 8,000, and then plug in DCOs, and then eliminate the transponder layer, and then just connect it directly to.
So are you saying a fixed box, which is like a pizza box, right,
Mhm.
is more efficient than a modular chassis with line cards?
Well, it depends from an application perspective, right? So all our fixed boxes are single chip fixed boxes, right? There's a single chip in it. So yes, there are some advantages, and the
Hmm.
advantages are in terms of debuggability, the fact that it's fixed, but there are definitely use cases where customers are looking for higher throughput, more radix,
Hmm.
more ports, port diversity, and they want control plane redundancy, meaning, my control plane goes down, I should be able to switch. And
Hmm.
they want fabric redundancy. What that means is that box is operational. If something goes wrong, I should be able to. But the challenge with fixed box is that while they're very efficient and very good, and power profile is very good, but they are designed for certain type of applications, right? So, um, but what my point was that customer that I'm talking
Hmm.
about, they were able to get rid of whatever box that they had router, and 8,000 fixed boxes are of such high capacity that you can
Hmm.
replace them with your existing boxes that are, half a rack, more than half a rack with same density, and use that. So that was one thing that really helped them. But the more important thing from
So
a teacher
so they
perspective,
replaced their older half rack with a single single RU fixed 8,000.
Fixed 8,000.
Is that what you're saying?
Correct. And then they removed. Then they were able to get rid of their transponder layer by using DCOs that you can plug into the fixed boxes directly. And
so the QSFP-DD ZR.
QSFP-DD ZR, and now obviously ZR Plus as well.
Okay. And so they had the same amount of throughput in both cases?
Yes, they were able to get same amount of throughput, and it all depends on the application, right? Some people will use passive mux ponder, passive mux, not mux ponder, passive mux to just mux the signals together. But this application, I don't think they used a mux. They simply connected directly 400 gig DCOs.
Amar, it's been really fascinating. I definitely learned a lot.
Oh, okay. I'm glad you did.
I know you're short on time, but is there anything else you wanted to touch on?
And I think I'm good, Pat. This was a very wonderful discussion. I really enjoyed it. Thank you so much for having me.
That was the 6th and final part of my conversation with Amar Khan. Subscribe to this podcast, and we'd really appreciate helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics, and leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog, no spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. Next time, we'll start a new conversation with a new guest. Until next time.